Number 13 says, according to a study conducted by a statistical organization, the proportion of people who are satisfied with the way things are going in their lives is 0.76. Suppose that a random sample of 100 people is obtained, complete A through E. So this one says, suppose a random sample of 100 people is asked, are you satisfied with the way things are in your life? Is the response to this question qualitative or quantitative? So the response is going to be, are you satisfied? So I would guess you have yes or no. Yes or no is not a number that we can do math with, so that means it will be qualitative. This is just kind of reviewing from the beginning of the year. So the response is qualitative because responses can be classified based on the characteristics of being satisfied or not. That looks good. Responses are qualitative because the number of people satisfied can be counted. Nope. That would be quantitative. That's what counting. Response is quantitative. Number can be counted, but we're talking about the response to the question. So are you satisfied? Yes or no. So A is going to be good. B, explain why the proportion is a random variable and what is the source of variability. Sample proportion P is a random variable because the value of P varies from sample to sample. Variability due to the fact that people may not be responding truthfully. B, the sample proportion is a random variable because the value of P varies from sample to sample. So both of those, same thing. The variability is due to the fact that different people feel differently. So yeah, that would definitely make the variability. Different people feel differently. But don't look good. The sample proportion P hat is a random variable because the value of P represents a random person included in the sample. So P itself does not represent a random person, but the value of P hat will vary from sample to sample. So that may look good. I think in B right now, the variability is due to the fact that different people feel differently. So yeah, that's the same conclusion. And then this one says the sample proportion P hat is a random variable because the value of P represents a random person included in the sample. So no, P hat is the overall people who are satisfied, the proportion who are satisfied with the way things are. So B looks the best. C, describe the sampling distribution. So if we want to describe the sampling distribution, we need to decide if P times 1 minus P times N is less than 10, and that N is less than 5% of the population. So, says since the sample size, which they did 100, the proportion that was satisfied was 0.76. So we're looking at 0.76 times 1 minus 0.76 will be 0.24 times 100. 18, so that's bigger than 10. We want the sample size is no more than 5%, so that means less than no more than 5%. And this is equal to around the 3 decimal places, 18.24, which is greater than 10. Approximately normal, mean 0.76, and the standard deviation. So with the proportion, the standard deviation the square root of P 1 minus P over N. So in this case, that would be 0.76. 1 minus that would be 0.24 over 100. So we're going to punch these numbers into the calculator. Square root .76 times 0.24. That gives us 0.0, 3 decimal places, 0.043. 0.043. D, in the sample obtained in part A, what's the probability that the proportion of people who are satisfied with the way things are going in their life exceeds 79? All right, so from here we're going to stack crunch and finish the rest. Exceed 79. Proportion, one sample with summary. So since out of 100, if they want to know exceed 79, we're going to say 79 success, 100 observations. 0.76 was our mean. We want to go greater than that. Critical value. Probability. Do we have a confidence level? Got too many dots. Okay, so I guess we don't need the full, we just need to do the regular Z, normal distribution, not proportion. So what we're doing, probability P greater than 0.79. So just going to do the normal distribution. Convert that to a Z. 0.79 minus 0.76 divided by standard deviation, which we got 3 decimal places, was 0.043. Okay, and we'll find that. So we're going to do normal. We're doing normal. Stack calculators. We're going to do normal. Greater than, mean is 0.76. 0.043 and 0.79 will be greater than 0.79. Probability 2427. And then using the distribution from part C, would it be unusual for a survey of 100 people to reveal that 70 or fewer in the example are satisfied? So 70 or fewer. So if we're doing, again, 70 out of 100, that'll be 0.7. That's where I got the 79 from. I get 70 out of 100. So we're doing the same thing. We want to know what's the probability that Z less than 0.7. 0.043, doing the normal distribution. So same mean, same standard deviation. We want to do less than 0.70. So we get 0.08. Unusual means less than 5%. So we want to probability was 0.0815. 0.0815. 4 decimal places, which is not unusual because the probability is less than. It's not less than 5%.